This is a video for working with American Community Survey census data within QGIS, and here we're going to download the product and go ahead and thematically map the variable from the product that we download. So to get started here, I'm looking at the census.gov website, previewing American Community Survey 5-year data structure, which is in this case 2009 to 2018. And we're going to be using, for this scenario, the 2014 to 2018 American Community Survey 5-year estimate. So right now this video is being recorded before the decennial 2020 census, so we don't have that full product. Using American Community Survey estimate makes sense this far out and close to the 2020 census taking. So what we need to do here is we can engage with the US Census programmatically through APIs, also through Python or through R, but somehow we need to get a hold of the data. And for this video, I'm just going to acquire a bundled product, which is going to be in a geodatabase format. So that's probably a pretty straightforward, easy way to get a hold of the data outside of doing it through some type of code or programmatically. To get that data, we need to actually go to the product itself, which is under the census.gov geographies, mapping files, and these are the time series. And these are what are called Tiger products or Tiger data products. And here we have a bundled geodatabase structure that has all the tabular data, but has that ships along with the geometry itself. And importantly, it has all the various census geographies that are available. So urban areas, tribal census tracts, zip code tabulation areas. We're going to be utilizing county for this demonstration. So I'm going to be downloading county, which I've already done. You can see the product here. It's at 705 megabytes here. But this can get you your main products. You can also do census tracts, block groups, but you have to download those at the state level because those are obviously very large. If you were to try to download the whole data set for all US states. Now, once you actually download the product, you need to decide what variables you're interested in mapping. So the location to do that, that's probably the easiest, is also online. And this is api.census.gov. We're looking at the 2018 vintage, and this is American Community Survey 5. So you can see in the address call, there's ACS5. Which is representing the 5-year survey. And this is obviously the 2018 product. So each one of these names on the left-hand side is the name of the column or the field. And when you bring this data into QGIS, you're going to have these named columns. And until you were to actually change that name, you're kind of stuck with those naming conventions. Now, what's important early on here is that you're reviewing the label and the concept. So the label is going to give you a general understanding of the theme, and then the concept is going to give you a little bit more of a described, expressed understanding of what it is, the universe of the variable, I should say. So let's take a look at what we have. So at the beginning here, we have different geographies, and then we get into this first estimate total. It says unweighted sample housing counts, and also sample count for population. When the American Community Survey is done, it's actually a sampling of households and sampling of the population. It's not a one-to-one count, so they're not going, it's not like the census. It's more of an estimated product based on a sample. So what they're telling you here in the unweighted table is what was that particular count? of the total population, what was the count. So you typically want to stay out of this table for mapping. It's not going to help you understand the population itself. And part of this video is we're going to normalize to the universal population per theme. And we want to understand that total population by theme. So let's go down to the first theme that's in the ACS data. So that's sex by age. So here we're going to see males and females divvied by or binned by years. Okay, so we can see males under 5 years old, males 5 to 9 years old, 10 to 14. So if you want to actually map the percentage of males 10 to 14 years old within we're going to use county as our geography, you could do that within this particular table that's 00E. For this demonstration, what I'm going to do is I'm going to be working with the total. Okay, so that's 001E, estimate total, sex by age, and then the males. So what I want to do is I want to have a universal population, which is the 001E, and then I want to understand how many males in total are within that population. So in this case, it's 002E. So what I've done is I've jotted down on just a little notepad those two variables that I'm interested in. So 001E is total population, and 00E is total male population. And then my equation to normalize is going to be males, and the total population is the denominator, times 100. So times 100 is going to give me my percentage expression. Okay, so this is the formula that we're going to use to normalize. So what we're doing is we're taking the total population and saying within the total population how many males, and give it a percentage expression. Okay, so we'll be using that in a second. In terms of data organization, this is what my project looks like right now. I've downloaded the geodatabase zip folder, which is gdb.zip. I'll show you where I got that in just a second. I've unzipped it, and if I take a look at the unzipped expression, this is what it looks like. So obviously this is unfamiliar. It's not something that we can just drag into Excel or into QGIS and work with immediately. So there's a process by which we get this into QGIS. I've also set up a dummy QGIS project called Census Demo. I've made a folder called Demo Exports because I'm going to be doing some exports here in a second. So let's go ahead and get started. So the first thing I need to do is where do I get this data? So if we go to the tiger line with selected demographic and economic data, that's where we're going to actually download the data. You can search for this. You can say census mapping files, and you should be able to get to this. And you can see it has all the years, the time series years. We're going to be using 2018, and this is giving us an estimate across 5 years, 2014 to 2018. Okay, and again, I'm using county. So I've downloaded this already. Let's get into QGIS now. So once I'm in QGIS, I have a blank project called Demo opened up. And the first thing I want to do is actually go get the data itself. So I'm going to use the data source manager. I'm using vector. And importantly, I'm not using file. I'm using a directory. Okay, so this is considered a directory. I have two options. I can use Open File Geodatabase, or I can use US Census Tiger Line. Either one of those is going to work. So in this case, let's go ahead and use US Tiger. And I'm going to point it to my folder. So I'm pointing it to the folder. Okay, I'm not going in and getting anything inside the folder. I'm just pointing it to the folder, and then I'm saying open. And then I say add. Okay, once I say add, I get a new pop-up that says, we'll select the feature, select the vector layers to add, And we can see under geometry type, there's a multi-polygon, which is this guy right here. So I'm going to select that, and then I'm just going to hold down my control key here, and I can get, or I'm sorry, my command key, and I can get anything else. I don't want to get all these tables that I'm selecting right now, so I'm just going to click off that. I do want my multi-polygon, and in this case, I don't want the counts, but I am going to map males, so I'm going to use that first age and sex table. Now you can see under geometry type it says none. That's because this is a table. It's tabular data. It's part of the geodatabase structure, and we're pulling out that one themed table and bringing it into QGIS. So we can see that we have tons of different variables here, or different themes that we can map within. You can go ahead and choose any of these. They're going to be the same structure as this demo that I'm doing for age and sex. So I just go ahead and hit the command key here and select those two and say OK. And it says, you know, I got a map projection issue here. Are you OK with this being the map projection? This is NAD 83, and that's OK. I'll just go ahead and say OK and say add it. Whoop. I'm sorry, close it. So here's my geometry now. You can see that the contiguous US is elongated here because, again, we have a projection issue. We'll correct that here in just a moment, doing what's called on-the-fly projection. So we have our geometry here, and we also have the table itself. Now, we do not want to open this table, because if we try to open this table, it's very wide in the sense that it has many different fields or columns. And we want to isolate those two, which is the total population and the male population. Okay, so we're not going to open that up right now. We're just going to preview the actual attributes of the geometry. So I'm going to go to Open Attribute Table. And here's what I have within the geometry itself. And there's one column, or actually two columns, that are important. For a land, this is the units in square meters. So the total square meter land area is the size per county. And there's also a water variable too. This US Census uses the A land to understand its area in terms of population density. Okay, because we assume that people don't live in water. So that's the reason why they separate it out as A water, A land. And we can use this column if we were doing population density. We're not doing population density right now. We're going to normalize based on the total population universe. We do need this column called GeoID underscore data. So this is the unique identifier for this particular county, and you can see each one of these counties. We have 3,220 counties. Each one has its own unique identifier. So this is a string column because we have a bunch of numbers, and then we have U and S for US. Okay, so it's a string column. We just need to keep this in mind. We're going to be using this GeoID underscore data to do what's called a table join in just a second. So let's go ahead and get out of this. And we've previewed that. We've seen what's in that table. That's all set. What I'm going to do now is I'm going to get this out of the geodatabase structure. So I'm just going to go to Export, say Save Feature As. In this case, I could save it as a geo package or as reshape file. I'm going to save it as reshape file. I'm going to point it to my exports demo folder that I made. So that's this guy, demo exports. And I'm going to call it a community survey.geo.2018. You can call it whatever you want. Okay, go ahead and save it. Just so I know that it's the geo. I'll save it in the NAD 83 projection system, that's fine. Now, here's the key. I can go ahead and deselect everything or select everyone here to export out. In this case, I only have a dozen or so columns. I'm just going to go ahead and leave it as default and export everything. Okay, and I go ahead and say okay. Does that, exports it fine. I'm going to get rid of the geodatabase instance, remove that, say okay, and then I'm going to go back and I'm just going to save this real quick. All right, so this project saved. I've saved a instance called ACS Geo 2018, which is a shapefile format. Now I need to deal with the tabular data. So what I'm going to do, this is sitting in a geodatabase right now. I do not want to open it up. So I'm just going to do a right click and I'm going to go to export, export save features as. I'm going to save it as not a shapefile. Okay, because this is tabular data, it has no geometry. I'm saving it as a comma separated value. Okay, comma separated value. I'm going to point it to my folder, demo exports. I'm going to call this, what do we call it? Let's call it ACS table sex age 2018. Say save. Now, if I were to export this and I leave everything clicked on, it's going to export out all these fields. And let me just scroll through and show you how many there are. Okay, we don't want a table that's that thick or wide because it's just going to take forever to process within QGIS. So what we need to do is we need to just deselect all, but we need to select on several columns that are critical for our mapping. So the first one, we'll go ahead and bring in the object ID. Here's the key. We need to have a GeoID. So in the tabular structure, the GeoID is a string. It's the same unique identifier that we see in the geometry called GeoID_data. Okay, so we're going to click on that. And then if we go back to the thematic variables that I'm interested in using, the universe is this one, E1, 1001 E1. That's the total population. And then the males are in this particular column, 1001 E2. And remember, I did all that research beforehand, so I know what columns I'm interested in. I'm not interested in anything else. And you notice that I'm selecting the E's as opposed to the M's. The M's are the margin of error for each one of those relative columns. Okay, so this M1 is referencing this E1, and this is showing us the margin of error. Now you're probably interested in actually looking at the margin of error because, again, American Community Survey is a sampling data set. Okay, it's not a one-to-one collection process. So what they're saying is, what's the margin of error per county? How accurate do we feel that this particular count is within this county? And sometimes that's important to disclose that the margin of error was high or the margin of error was low within this particular geography. For this demo, I'm not going to worry about the margin of error. I'm just going to assume that the 5-year survey here across all counties is stable. Okay, so I go ahead and I'm going to export just these 4 columns. So it's object ID, GeoID, the estimate 1, and the estimate 2 for where the males are located. And I go ahead and under the CRS, it says, listen, this is an invalid projection because it's not seeing it holding geometry. That's fine. Under geometry, we can force it to be no geometry. Let's go ahead and do that because remember, we're just sending it out as table data, and we're going to say OK. Exports out, and it may give you an error where it says this is an invalid data source. Okay, that's going to be OK here. We're going to get rid of this, and we're now going to drop in under delimited text. So I'm no longer adding a vector. I'm going in as delimited text. I'm going to add it in. I'm going to point it to the file. In this case now, in my demo exports, I have the table saved now as a CSV. I say open. And it gives me a little preview here of what my data looks like. So here we have the object ID, the GeoID, we have the universe, which is E1, and then we have the theme variable, which is E2. So we can see in this case, this very first preview here, there is a total population of 55,200, and 26,874 of that total population are males. Okay, so we're going to normalize this in the second to get a percentage number. Now, we want to import this in under geometry definition, no geometry. And we say add. Close. Okay, now we can go ahead and open this up. This is easy to open up because it's not that thick. So we just have the 4 columns across each county. So now let's go ahead and get our percentage expression. So we're going to go to Open Field Calculator. We're going to create a new field here, and we'll call it PCT male. So this is the percentage for male. It's going to be a decimal number, okay? And our expression now is going to be fields and values. We're going to get the variable, which is the males, divided by the universe population per county times 100. 100. Okay, it likes that expression. It gives us a little preview number, and we go ahead and say OK. Great. So we're done there. We've created that in the table. So once we actually have the table constructed and we have our variable that we're interested in mapping, we can go ahead and begin our table join. So to do the table join, what we'll do is first target the geometry. So we go ahead, go down to properties for the geometry itself. And here we're going to go to joins, which is in the middle of the dialog on the left-hand side. So we go to joins. We're going to create a join. So we click on the plus green down at the bottom. That gives us a new join. And in this case, we're only seeing one possible join, which is the table itself. In the join field, in this case, it's going to give us the options out of the table. So our GeoID is what will be the join field for the table. And then the target, which is the geometry itself, is going to be the GeoID. So these two are going to match, the GeoID and the GeoID underscore data. Although the column names are different, the actual data inside the column is the same across the two. And we have other options here. We can go and select specific fields that we want to include. We'll just go ahead and accept all the defaults here, and we're going to cache it into virtual memory. So we say OK, say apply, and say OK. And then what we can do is we can go ahead and open the attribute table and make sure that the join took place. And if it did, we should be able to see on the far right-hand corner. Let me actually go ahead and collapse this down a little bit so that we can see it better. On the corner here, we can see that we have our percentage way at the far right-hand corner. So this is the variable that we want to map. Okay, so let's go and get back into our mapping. And what we're going to do now is go ahead and thematically map this. But before we thematically map it, we want to do two things. The first thing is that we want to export this out now. So we're going to save the feature as. Remember, it's joined, and we can see all our columns. This might be a time to get rid of some of these columns that we don't need now. I'm just going to go ahead and export it as is. So we would go to as shapefile. We're going to point it to the exports folder. Okay, so I might call this ACS join. Okay, 2018 maybe. There we go. And I want to make sure that this is Esri shapefile. It's going to export with a coordinate system, in this case NAD83. I'm including all the variables. The geometry type is going to be automatic in this case. And we go ahead and say OK. Take a second to export it. And then we're going to get rid of the old layer. So we'll remove that and say OK. And what we want to do at this point is go ahead and adjust the coordinate system on the fly. So by on the fly, we're not going into the layers and adjusting the actual coordinate system within the layers. we're simply going to do the whole project map canvas. So we do that by going down to the lower right-hand corner and clicking on the coordinate system there. And we need to pick something that's going to work for United States, and something like North American Albers equal area conic is good because this gives us an equal area representation of the features. So it's going to represent each county according to its shape and area much better than the current projection system. So let's go ahead and we can use that. That'll be good. Let's say apply and say OK. And we can see what we get. We get something that looks much more like it should. Okay, so at this point, we're ready to go ahead and thematically map the data. So if I go to Properties, under Properties, we're interested in symbology. And up till this point, we've been working with categorized and single symbols. Now we want to explore graduated options. So we click on graduated. The value is going to be the last position, so it's table _3. So you want to make sure that you understand the position of your variable that you're interested in mapping. So I'm going to click on that. And this is the males, the percentage of males. And the color, I want to make sure that I'm picking a color appropriately. So there's several different options here. You can do all color ramps. You can see that there's lots of options here. Some sequence between two hues, others stay within one hue. So you want to make sure if you're picking one of these that you're picking one that maybe is related to the theme. So for instance, green works really well for money. You want to be careful whenever you're doing any type of political mapping that blues and reds are used correctly, if at all. So just be careful when you're choosing your colors. In an intuitive sense, certain colors go with certain themes a little bit better. So let's go ahead and I'm just going to do an orangish color for this. So I'll click on oranges. And so my low values in this case on the color ramp are going to be towards white, and my high values are going to be towards a dark orange. So we have methods. Once we pick our color, we have a legend format. This is going to be percentage, and I got precision. I can also trim it, which I have clicked on here. We have different options. So we have a quantile, equal counts. We have equal interval, logometric, natural breaks, pretty breaks, and standard deviation. I'm going to go through natural breaks, equal interval, and equal count, and take a look at what those give us. We want to be choosing typically class breaks between 3 and 7. More than 7, it's hard for the human eye to decipher difference, and below 3 doesn't really give you a lot of variance. So 5 is sort of the default. We'll stick with 5 for right now. So we're going to do equal counts across 5 different class breaks, and let's take a look at the histogram. So I'm going to say classify. So we can see that in the resulting thematic, values from 41 to 48 are going to be classed to this white color, 48 to 49 to a light orange, and then 50 to 78 to a dark orange. Let's take a look at the histogram. So we go to the histogram, we load the values, and we can see our breaks across the histogram of the data. And we can see, importantly, where values are falling within each one of the buckets. Okay, so what it's telling us is that we go from the first value in the data set to the first break, which is at 48.64, and it's showing us all the values that fall within that first break. Then we have the second one, the third one, the fourth one, and the fifth one. So we can see the distribution of our data within each one of the breaks. And so with this particular method, what we're doing is we're creating groups of equal number of values, Okay, so we say apply and say okay. And This gives us a decent map. We can see the pattern overall. Inverted, this might work also. So here what would happen is in the east here we would see darker colors for a low percentage male and lighter colors for a high percentage. That might actually work better. Generally we can see in the southeast that the percentage of males is lower than 50%. And then out in the west we're at 50% or higher generally. So let's go back to properties and try another method. So here let's go to equal intervals and see what equal intervals gives us. We're going to stick with 5 again. Go to the histogram, load the values, and here we can just see in the histogram that we have these are sort of equal bins now. So what's happening from the minimum value to the maximum value in our data set, it's creating even sort of buckets here, okay? So 71 to 78, 63 to 71, 56 to 63, 48 to 56. And it doesn't really care how many things it's putting into those buckets. It just cares that the buckets are the same size, the same width. And we can see what happens here is that on that last class, the highest class, we really only have sitting in the corner here looks like one county. So this is the problem with this particular method is that it's not, quote, evenly distributed amongst the data set itself. So let's go ahead and apply this and see what we get. So here, this is really going to pick up the highs and the lows. We don't really get those middle classes significantly. Let's head on back to properties and let's try natural breaks. So if we go to natural breaks now, let's go to the histogram. With natural breaks, this is essentially an algorithm that fits the data quite well. So typically if you're doing an out-of-the-box mapping, natural breaks is typically a good method to use because it forms the breaks relative to the data. And say apply this and let's say okay. So this works out pretty well. So with natural breaks we see the west versus the southeast, but importantly everything is evenly distributed across the class as well. So those are 3 typical thematic mapping methods, and you can see the differences that you achieve through those methods. And it's important as the cartographer that you pick a method that is fitting your data sufficiently and as, quote, honestly as possible. So you can use one of these methods and really sort of hide or push a way of finding that you may be trying to either highlight or actually trying to avoid. This is what's often called lying with maps. We can also do something called pretty breaks. I'll just show you what pretty breaks looks like. So with pretty breaks, what we're doing is we're just getting these nice even breaks. If we look at the histogram, we can see that we get these kind of even segments across the bins. Say apply and say okay. This gives you a nice clean legend, but it may not produce the best map. Okay, so once you get to this point, then when you're actually doing map layout for all the states and all the territories, you have to use multiple frames. So I'm just going to call this layout demo layout. And with demo layout, what I'm going to do is draw out the first box. This will be the main map frame. Okay. So what I want to do here is make it so that this particular feature is highlighted. Okay, let's bring down the scale. Let's bring it down to 15. That's a little bit big. I'm going to go to 20, maybe 25. Okay, so I might have something like this as my main map frame. And then if I want to show territories, I'm just going to click on this real quickly. I'm going to make a new box. And I may then want to center this on Puerto Rico. Change the scale pretty dramatically. Okay, maybe even a little bit bigger. Okay, so I might do something like that. Move it over a little bit. And then I would make a new frame for Alaska. So you can kind of see what's going on here. We're making multiple frames. And then I'm going to pull it down. And I might bring this down to 60. And pull it down. Let's make this 50. Yeah. All right, and then I'm locking these up. Now, what's critical is when you make your scale bar, you want to drop in the scale bar, say OK. And for the scale bar, you don't want to have it mapping map 3. So currently I'm at map 3, which is Alaska. I want it to go to the main map feature. So this scale bar should sit with the most prominent feature on your layout page. And then what you can do is you can drop in some text over here, and you can say something like not to scale. So we could say or you could say, Alaska not to scale, Puerto Rico not to scale, however you want to do that. But here on one map page, you're showing all the territories. It's difficult to do without multiple map frames just because they're so spread out in terms of geographic scope. So hopefully this video gives you a sense of moving from the tabular data, the geometry that's sitting in a geodatabase, moving into QGIS, getting the table join done correctly, normalizing the data. Remember, we want to create a percentage typically, and then actually thematically mapping it. And when we thematically map, we want to make sure that we're choosing a method that we feel best represents the larger pattern of the data. Remember, you got two things going on. You're looking at the distribution of the data through the histogram, but you're also looking at it through a geographic perspective. So you want to make sure if you have particular spatial patterns that are important. So one of the particular spatial patterns that's important here that this particular map that we're looking at right now doesn't pick up very well is the difference between male population in the West versus in the Southeast. In the Southeast, it's much more sparse. In the West, it's much greater. So in that case, we would want to highlight that larger spatial pattern that's a big part of this particular variable in American Community Survey data. So think about what is the message that you're trying to convey and what is the method that's going to best represent that particular theme and the point that you're really interested in conveying as the cartographer.